Okay, section 6.6. We're going to look at two different pieces. One is on solving triangles. And just a reminder, that means find all sides and all angles. And the other piece is on applying trigonometry. So maybe looking at directional questions or percent grading questions, things like that. Starting with solving triangles, find all angles and side lengths. So what I like to do to keep myself organized is I like to write out a list of all the pieces that I need to know and all the pieces I know. So I'm going to start with that on the left. I need to know angle J, angle K, and angle L. I also need to know side length JK, JL, and KL. Okay, so those are the 6 angles and sides that we need to solve the triangle. So let's put in the ones that we know already on our list. So KL is 6.7 centimeters, and angle J is 61 degrees. Are there any other angles that we know? I'm hoping you're thinking yes. We also know angle L. It's the right angle, and so it is 90 degrees. Now, if we want to find angle K, we know that we have an understanding of triangles that tells us there's 180 degrees in a triangle. If it's a right triangle, we know that one of those angles is 90, which leaves 90 degrees for the remaining 2 angles. So angle K must be equal to 90 degrees minus 61, which gives us 29 degrees. Okay, so all that we're left now to do is to find length of JK and JL. One of the things when you're solving triangles, because you're creating new pieces of information, you might be tempted to use them, but I highly recommend that you use the given information only when you can. Oops. So the given information would be the 61 degrees and that 6.7 side length. Okay, let's start with JK first. That's this length here between J and K. And if I keep 61 as my angle of interest, I know that 6.7 is the opposite and JK is the hypotenuse. The trig function that relates opposite and hypotenuse is the sine. So the sine of 61 degrees must be equal to the opposite, which is 6.7 over the hypotenuse, which is just JK. You can use another letter for this if you'd like, but I'll use that. When our unknown value is in the denominator, we know that we first start by multiplying by JK on both sides. JK divided by JK will become 1, and we've now removed it from the denominator. So we have JK on the left times sine of 61, and that's equal to 6.7. And we now want to get JK on its own, but it's being multiplied by sine of 61, so we're going to do the inverse of that, and we're going to divide by the sine of 61 on both sides. These will simplify to be 1, and JK is now equal to 6.7 divided by the sine of 61. And if we pop over to our calculator and throw that in, we should end up with 7.66 centimeters. Now, if we're asked to give our measurements to the nearest tenth, that's 1 decimal place, so we would round it up, and that would give us 7.7. On to JL. So to find JL, That's this side length here. And that is the adjacent to the angle we know, or our angle of interest. And here, now we know the hypotenuse, so we could use that, but because we want to use the given information, let's use the opposite and the adjacent. So that's the tangent function. Tangent of 61 degrees is opposite, which is 6.7, over the adjacent, which is what we're looking for, JL. And same as the question before, multiply by JL on both sides to get it out of the denominator. We end up with 6.7 on the right, and we have JL times the tangent of 61 on the left. Then we want to get JL on its own, so we're going to divide by the tangent of 61. And JL is now equal to 6.7 divided by the tangent of 61, which I believe gives us 3.71 centimeters. Rounding that to the nearest tenth would be 3.7. And now we have solved our triangle. We have all three angles and all three sides. Question 46. In right triangle KMN, angle M is 90 degrees, KM is 8 centimeters, and MN is 9 centimeters. Solve this triangle. So this one's tough because we don't even have the triangle yet. But we have some pieces of information. We know that M is the 90-degree angle. And we have KM is 8 and MN is 9. So there's one that's going to be a little bit longer than the other one. Let's say that this is angle M, 90 degrees. And KM is 8 centimeters. And MN is 9 centimeters. So we just have to take our time, make sure we draw our triangle so that it looks correct for the values we've been given. And let's list all the pieces of information we need to find. We need angle M, angle N, angle K, and we need side length MN, MK, and NK. Some of these we already have. So starting with the angles, we already know that angle M is 90 degrees. So that's one that we already know. Angle N we don't know, nor do we know angle K yet. Side length MN is 9 centimeters. Side length MK is 8 centimeters. And we need to still find NK. So we have some options here as to what we want to do first and how we go about doing it. If I wanted to finish up the side lengths and find NK first, I have two sides and I'm looking for a third. So we know that that is the Pythagorean Theorem. So we can go 8 squared plus 9 squared must be equal to the side length NK squared. And to solve this for NK, we have to undo the squaring. So we would square root both sides. We end up with NK is equal to the square root of 8 squared plus 9 squared, which I end up with 12 centimeters. Okay, so that's one done. We can add that one to the diagram, but like I said, it's not a given piece of information, so I wouldn't use it. Next, it doesn't matter if you choose N or K to find. Let's start with angle K. I'm going to label my sides. I have hypotenuse straight out from angle K. I have the opposite and the adjacent. Now, the ones I'm going to use for this one will be opposite and adjacent. I'm trying to find angle K, so that is going to be the tangent function. So the tangent of angle K must be equal to the opposite, which is 9, over the adjacent, which is 8. And now to solve for this angle K, we have to undo the tangent function. So we'll take the inverse tangent of both sides. So K is now going to be equal to inverse tangent of 9 over 8. And that we can stick in our calculator. When I do that, I end up with 48.4 degrees. Perfect. So now we have some options on finding angle N. Because I said we wanted to use given information, we could do this again with the tangent, but we would need to switch 8 and 9 because the opposite and adjacent would change. So this would now become the opposite, and this would become the adjacent. So we could say the tangent of angle N is equal to the opposite, which is 8 over 9. And we can solve this for angle N. Is there any other way that we could find angle N? Yes, because we know the three angles of a triangle add to 180. This is a right triangle, which means the two acute angles, or the smaller ones, add together to be 90. We could also go 90 minus 48.4 degrees and figure out what that gives us, which should be 41.6 degrees. This is actually a good way to check your work. You could leave this until second and solve for angle N with a tangent. So once we simplify this, we're going to end up with N is equal to the inverse tangent of 8 over 9. And when we plug that in our calculator, we should also end up with 41.6. So a way to check your work would be to do this using trigonometry, but then check your work after to see if the two angles match up. But either way, we get 41.6 degrees, and we have solved this triangle. You're on your own to practice questions 47 and on.